Okay, here's where we're headed. Just a few minutes ago, as a homework problem, we solved that equation. And we only have one technique for solving quadratic equations at this point, and that's to factor. So we saw that this factored as x minus 5, x plus 2 equals 0. So we get x equals 5, x equals negative 2. Where we're headed is, what if I changed that problem ever so slightly and made it so it wouldn't factor? X squared minus 3x minus 11 equals 0. Unfortunately, x squared minus 3x minus 11 doesn't factor. Does that mean there's no answers? Just because you can't factor? No, unfortunately. It doesn't mean there are no answers. That has answers, but finding them is more difficult. And this is where we're headed. We're going to learn techniques for solving equations that don't factor. What we're going to find when we want to solve equations that don't factor is they're going to end up having square roots in them. So this has answers. This has two answers. Both have square roots. So before we can learn how to solve this kind of equation, we need to do a little bit of review of square roots. And in this section, section 9.3, that's what we're going to talk about, simplifying square roots. So I might give you some real easy ones, and I might say simplify. The square root of 25. And without doing much work, without really thinking at all, you would tell me the answer is 5. Or I might ask you to simplify the square root of 100. And you would tell me the answer is 10. Square root of 81. 9. All right, so those are the easy ones. So how do these get harder? I don't even need decimals and fractions. I don't even need bigger numbers. What if I ask you to simplify the square root of 45? You make it 3 square roots of 5. Excellent. And how did you get 3 square roots of 5?
Well, basically, do a tree diagram and 9 times 5 and get it based on 9.
Perfect. What you're doing is you're trying to take the number 45 and factor it. But you don't want to factor it any old way. You want to factor 45 so that one of the terms is a perfect square. So I could factor 45 as 3 times 15, but 3 times 15 doesn't do me any good because I don't know the square root of 3 and I don't know the square root of 15. 45 also factors as 9 times 5. And that's helpful. Why is that helpful? Because the square root of 9 is a nice number. The square root of 9 is 3. So we're going to write this as square root of 9 times square root of 5. And the square root of 9 is a nice number. It's 3. So to simplify square root of 45, we would write it as 3 square roots of 5. Questions on that one? All right, how about square root of 60? Can you simplify the square root of 60? Well, the whole question is, can you factor 60 in any useful way? Can you factor 60 so that one of the pieces is a perfect square? $15 times 4. 15 times 4 is useful. And I heard people saying things like 10 times 6, that's no good. 20 times 3, that's no good. Why is 15 times 4 the right way to factor that? Because 4 is a perfect square. What's the square root of 4? 2. 2 square roots of 15. Junior.
I would say even if we used to use 7 times 6, what I learned from the past was when you put a tree diagram, when you break it down, any two numbers you have to just take out. So you have 5 and 3, so you just times 5 and 3.
Okay, so what he's saying,
It's just a longer process of work.
yep, what he's saying is the way he learned to do it is he did it with a tree diagram. So he took 60 and he wrote it as 6 times 10. And then he realized 6 factored more. 6 factored as 2 and 3. You said 3 and 2. I wrote as 2 and 3. And 10 factors as 2 and 5. And so the technique is, if you have a number that repeats, the 2, that's the number that goes out front, anything that repeats. And anything left over, anything that doesn't repeat, you multiply, and that's what ends up under your square root. That's perfect. All right, how about square root of, I don't know, anybody got another good number? Make up a good number. 24. Can you simplify the square root of 24? Bless you.
Six.
24 factors as 6 and 4. And that's useful because, once again, square root of 4 is 2. So this factors as 2 square root of 6. How about square root of 30? Can't. That's right. Not all numbers can be simplified, not all square roots. Because if you look at 30, 30 is 3 times 10, or it's 6 times 5, and that's it, right? There's no perfect squares in there. So not all square roots can't be simplified. And here's an example. Square root of 30 can't be simplified. Okay, the other thing you're going to see in this section is a process called rationalize. And rationalize is a big fancy word for get rid of square root on bottom. So these are going to involve fractions. And I might give you something like 5 divided by the square root of 2. And the directions might just say simplify, or they might more particularly say rationalize. What that means is I want to rewrite this fraction, and I want to write it so that I don't have a square root of 2 on bottom. It's going to be okay if I have a square root up on top, but not one down on bottom. What do you do? Any ideas? Multiply top and bottom by square root of 2 is the technique. We multiply top and bottom by whatever that square root is on bottom. In this case, it's square root of 2. So we multiply top and bottom by square root of 2. Why? Why does that help? What's the square root of 2 times the square root of 2? Square root of 4. And the square root of 4 is a nice number. It's 2. And up on top, we end up with 5 square roots of 2. Questions on that? All right, how about 10 divided by the square root of 6? What would you multiply by? Square root of 6. Whatever that square root is on bottom, that's exactly what you multiply by. Up on top, we have 10 square roots of 6. On bottom, we have 6. Not quite done this time, though. Why not?
We could divide 7. You could break that down to 6.
10 and 6 reduced. 10 and 6 reduced by 2. So our final answer, we would write it as 5 square root of 6. That one doesn't change. 5 square root of 6 over 3. 10 and the 6 we can reduce by a 2, so we do. Questions on that? All right, the last sort of thing you're going to see in this section. You might have 6 plus the square root of 63 divided by 12. And they ask you to simplify. What would you do? Any ideas? Okay, what you're doing is you're multiplying top and bottom by 6 minus the square root of 63. That's an interesting process. That would be called rationalizing the top. The problem with rationalizing the top is it would put a square root down on bottom, and typically we don't like square roots on bottom. So not a bad idea, and that's a process that we do a lot in my calculus class, rationalizing the top, but we're not going to do that here. I heard a different idea, something about the square root of 63. Simplify your square root of 63 first. 63 is 9 times 7. So this is 6 plus the square root of 9 times 7 over 12. That's 6 plus 3 square roots of 7 over 12. So we simplify our square root as much as we can first. Then what? And then we look to simplify more. How can we simplify more? Everything not in a square root can be divided by 3. And so we reduce. We divide everything by 3. When we divide by 3, we're left with 2 plus square root of 7 all over 4. Questions on that one? I have a question for you. Can I do this? Can I just reduce right from the beginning? No, why not? Well, I haven't simplified my square root. That's true. But in any case, is it legal to cancel like that? Can I cancel up and down like that? Probably not, or the teacher wouldn't bring it up, right? Let's make it a little easier. What if I gave you 6 plus 5 over 12? How much is 6 plus 5 over 12? It's 11 over 12. If I cancel this way, I end up with 1 plus 5, that's 6. 6 over 2 is 3. Are those the same answer?
No.
No, certainly not. Which one's right? The top one. Why is the top one correct and not the bottom one? Lauren, why is the top one correct and not the bottom one?
Because when you reduce, they add equals, like they equals.
True, but why can't I reduce that way?
Because you're changing
All right, here's the answer. Here's the correct answer.
You have to reduce by everything, don't you?
You do. If you're going to reduce, you have to reduce everywhere. This big fraction bar, this is something people tend to forget. That big fraction bar is really a set of parentheses. And in the order of operations, what do you have to do first? You have to do inside parentheses first, don't you? So I can't cancel the 6 with the 2 because I need to be able to do inside those parentheses first. If you have a fraction, the only time you can cancel is like when we did up here. The only time you can cancel is when you can cancel everywhere. If you can only cancel in 2 of the spots, it's not legal. All right, let's try one more of those. How about, I don't know, 10 plus the square root of 20 over 2. What would you do with 10 plus the square root of 20 over 2? 20 is 5 times 4, so that's 10 plus the square root of 4 times 5 over 2. So that's 10 plus 2 square roots of 5 over 2. Square root of 4 is a nice number, it's 2. And then everything can be divided by 2. Since I can divide in all 3 spaces, it's a 5, that's a 1, that's a 1. Final answer. 5 plus square root of 5. So sometimes the fractions go away completely. That's nice. Usually they don't. Questions on that?